In this video, we're going to learn the rules of a game that is going to help us show that the set of real numbers is uncountable. And this is the game of dodgeball. So the important thing here is that we understand this game very well, because later you're going to have to create an argument based on this game to actually show that the set given by the interval between 0 and 1 is uncountable. And after that, you will be able to extend that notion to the set of all real numbers. So let's get started. So how is this game? Well, first of all, here I'm showing you the board of the game. And it goes like this. So each player is going to have 6 turns, and it happens in the following way. Player 1 will fill the first row with crosses or knots, with 1 in each box. And then player 2 will place either a cross or a knot in the first box in their row. So you can see player 1 has an array, a 6 by 6 array, and player 2 just has a row with 6 entries. Okay, so what happens next? Well, in the second round, player 1 will populate the second row with X's, O's or knots and crosses, complete that row, and then player 2 will write a cross or a knot in the second box of its row. And that's what we're going to be doing. So the second box of player's 2 row, and then we go to the next round, and that means player 1 needs to enter crosses and knots in the third row, complete that row, and then player 2 will write a cross or a knot in the third box of their row. Okay, and the game ends when player 1 has completed all the 6 rows and when player 2 has filled in all the 6 boxes in their row. Okay, so now that we have this, how do we decide who wins the game? Well, player 1 is going to win if any horizontal row in the 6 by 6 array that they have is identical to the row that player 2 created. So player 1 matches player 2. Now, player 2 will win if player 2's row, like all the 6 letters, is different from each of the 6 rows produced by player 1. So player 2 dodges player 1. So what this means is player 1 wins if there is one row of the ones created by player 1 that is equal to the one created by player 2. Player 2 wins if their row is different from each of those 6 rows that were created by player 1. Okay, and now let's play the game and see what happens. So here, player 1 decided to do cross, knot, knot, cross, cross, knot. And after this, player 2 says, okay, I'm going to do knot. Then player 1 does knot, cross, 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 and then player 2 chooses knot. And then player 1, round 3, does cross, cross, and then followed by 4 knots, and then player 2 chooses a cross. Player 1 in the 4th run says, okay, I have 2 knots followed by 3 crosses and then a knot. And then player 2 decided to choose a knot. And then we continue this. And you can check very carefully that player 2 wins. The last row here was very close for player 1. If you can see, row 6 of player 1 is almost identical to player's 2 row, except for the last entry. So then, actually, there is a winning strategy here for one of the 2 players. That means that if one of the 2 players plays smartly, they can always win. So which player do you think would be, and what do you think that strategy? Here I have another example of another game. Try to study it and see exactly how you can win this game. That is your aim. You have to see what are the different combinations and what is the strategy that one of the 2 players can use to make sure, like be 100% sure that they are going to win, no matter what the other person does. And then, once you figure that out, you should apply this winning strategy to lists of real numbers. So here you have a list of real numbers that are between 0 and 1, and they're written as a decimal number. And then you should use that method similar to the one in the strategy. I'm calling it Cantor's dodgeball. You're going to see why Cantor's later on. To write a real number in decimal form between 0 and 1 that is not one of these 8 numbers in the list. So I'll leave you with that, and then with all those ideas you will be able to prove that the interval 0, 1 is actually uncountable.